Hello, my name is Arundeep Singh. My student ID number is 120888733 and my project name is irrigation control system. Let me show you the prototype. This is the prototype. Talking about the introduction, agriculture is the booming industry of all the time that exceedingly relies on water resources for its existence, as it accounts for 70% of all water withdrawals globally. Water lays an essential foundation stone of the agriculture sector that is exploited by the farmers on daily basis. As a result, the, the water scarcity problem has become a greater concern in the present time. Competition for water resources is expected to increase in the future with a particular pressure on the agriculture. Therefore, in order to overcome these problems, it is essential to optimize the use of water resources in agriculture sector so as to achieve the sustainable development. This particular project focuses on implementing a cost-effective method that can take real-time decision about when and how much water should be provided to the crops with a minimum human intervention. It comprises of both hardware and software components that control and monitor the entire process. It consists of a temperature and moisture sensor, solenoid valve, a microcontroller PIC18F4321, and MPLab X software that I has used, and the liner optimization system depend on the soil humidity reading that are acquired from the soil moisture sensor that sends signal to take necessary action. Based on the reading provided by the sensor, the controller sends the instruction whether the water should be supplied to the crops or not. The proposed method ensures that all the crop acquire the accurate moisture of water for their healthy growth. So there are several advantages of this project. The first one is the efficient use of water. The second one is that it is very cost effective. It supports environment sustainability, reduce water expenditures, and decrease the human intervention, and it is very user friendly. With modernizing technology and automation use of irrigation control system is a boom to the agriculture industry that can surely minimize the water scarcity problem. So talking about the aim of my project is that the agriculture has developed to a greater extent, but there are still some area which need focus, and first one is irrigation. The heavy dependency on climate and weather condition make it very difficult, as well as the groundwater is going very lower these days, and there is wastage of water. Rainfall is very less as the due to the global warming. These are the some problems that are being faced by the farmers today. In addition to this, the present system of irrigation require usage of pump which need proper attention while working. This involves continuous check that stop the person from doing other activities and focus only on one part, which make it very boring and very tiring work. Therefore, irrigation control system is the best solution for overcoming these problems. It needs just that what type of crop, soil and climate they are having, so it will give the moisture according to it. And talking about the requirement, the software requirement that I have used in this is the MPLab X IDE 4.20. And talking about the hardware, the first sensor that I have used in this project is temperature sensor, and it will just give the information. The use of this is it just gives the information that what is the temperature in the air. For example, it is showing here 25 Celsius. So if I just hold it and just increase the temperature, So it just tells the real-time temperature in the air. The second, and the talking about the connection, the rightmost pin has gone to the ground, and the center one is connected to the resistor, which is further connected to the 5 volt, which is coming from this sensor board. The 16 pin is the 5 volt pin, and the resistor is connected to it, and the other and one more wire is going to the RA0, which is a port given for the temperature sensor. So this is the connection of the temperature sensor. Talking about the second sensor that I have used in this is the soil moisture sensor, and the soil moisture sensor has 3 pins. The first pin is, as you can see, is minus, second one is plus, and third one is S. So the minus pin is going into the ground. Let me show you. Minus pin is going into the ground, and the second pin, which is +1, is going into the 5 volt, which is also connected to the sensor port, and the third pin, which is S, is given to the RA1, which is assigned port to the soil moisture sensor. And third and the last thing that I have used in this is the solenoid valve, so which is further connected to the relay. So the port number, if I talk about the first pin of the relay, which is the center one, red one, is connected to the ground, and the second pin is which is green one of the relay, is connected to the 5 volt. The third one, yellow wire, is connected to the transistor of its third leg. It is connected to its third leg, and further the transistor is connected to a resistor, which is which is connected to the RB2, which is the assigned port for the solenoid valve. And the fifth pin is blue one of the relay, which is connected to the solenoid valve, and I have given the valve a 12 volt. So from this power supply, let me adjust it to the 12 volt. So the 12 volt is given, and now let me show you the basic concept that I have used. So in this, what I have done is that whenever the moisture goes less than 30%, the solenoid will get automatically on, and it will go on until the 70%. When the moisture is reached 70%, it will automatically close the valve. So let me just demonstrate. Right now it's 0%, it means the valve is on right now. So if we put the moisture sensor in the water, just to increase the moisture, so as you can see, the moisture is increasing. Now the valve is closed because it's above than 74%. So if I pull it out more, the soil moisture as it is decreasing, and if it reach 30%, now the valve is open. As you can hear the sound of the valve. So it will just show you how this project is working. So this is an irrigation control system that I have made. Thank you.